Hello, this is Daily Space Camero. In this channel, I'm everyday broadcasting some of the space business and the space technology news that catch my eye. So starting the new day, and if you are interested, you can listen to this kind of news. And if you're interested, also you can go to the link in the description section below, because I put some details like a link in there. So my intention is to briefly explain what is going on around the space news and like what happened like yesterday and stuff. And so if you got interested, you can go to link in the below. So let's begin. So today is 2024 March 30th on Saturday. So I picked up some news. I got two news right here. One is that China appears to be trying to save stricken spacecraft from lunar limbo. So second news is from Japan. Japanese lunar lander company ispace raises 53.5 million USD in stock sale. So let's begin. So as you know, probably you don't know, but China is trying to reach to the far side of the moon. They send like spacecraft and stuff. They are so ambitious, trying to catch up with US or NASA. So they are very serious about these missions. So they do several missions. The one mission is called this DRO missions kind of things. So they already launched several satellites in the LEO and to pass the data. So they expect when the lunar lands on the other side of the moon, they do some exploration there and they send the data back to Earth. They need to relay that data to the through the satellite, and they need to pass it back to the Earth because they cannot just directly transmit the data from the other side of the moon to the Earth directly, right? So they launched some DRO-A. DRO is the orbit name. I'm gonna come back to it in short. DRO-A and DRO-B spacecraft, and March 13th. However, hours later, the first acknowledgement on mission said they launched successfully. However, insertion was not accurate because of the rocket Yanzhang 1S upper stage malfunctions. So the upper stage encountered abnormality during flight, causing the satellite to fail to accurately enter the preset orbit. So what they're trying to do is to basically save these satellites back to the normal orbit by trying to do some burn when it hits to the shortest distance, closest distance to the Earth, and they need some burn to recover this kind of misinsertion. So this DRO-A BR pair are designed to communicate, as I said before, to communicate from distance retrograde orbit, this DRO, distant retrograde orbit, with another satellite named DRO-L in LEO. This is already launched in this year February. DRO is a high lunar orbit that moves in the opposite direction to the moon's rotation around the Earth. So this is the opposite direction movement with the moon's rotation is this retrograde. The terminology means the distance means a little bit far. It's gonna move around a little bit far distance to the moon, and with the retrograde like to the opposite direction. So China has yet to provide an update on DRO-A and B satellite. It is possible that next orbit rising burn, when the spacecraft is at the closest approach to the Earth, the perigee, could raise its apogee, or the furthest point from the Earth, to the lunar distance. The spacecraft would then need to perform another burn to enter its intended lunar orbit. It is unknown how much the unplanned use of propellant for raising its orbit to reach the moon will impact this mission. So this mission like I said, this is one of the missions that they're trying to do. So this is not appear to be the major part of the China's lunar plans, and it would not have a big impact on the country's exploration program. It is rather a technology and orbit testing mission that could play a role in wider lunar ambitions. So this another ambition is this Chao missions to Chao 2, lunar communication relay satellite launched March 19 as a precursor to the Chang'e 6. This is a real lunar lander, the far side sample return mission. So they want the sample make it back to the Earth. So I'm going to talk about a little bit of the distant retrograde orbit, little bit if you don't know about it. So this distance retrograde orbit is highly stable. So this is stableness is the key. The spacecraft orbit around the moon that travel in the opposite direction. This opposite direction means this retrograde, what this means, to the moon's orbit around the planet. Some key points are the orbit is a little bit distant in the sense that it passes above the Lagrange point. This is kind of stable points rather than being near the moon. This makes it very stable orbit that requires little fuel to maintain. So this is also key points, little fuel to maintain. So they don't need to burn a lot of times to maintain the orbit. In DRO, the spacecraft orbits the moon in the opposite direction to the moon's orbit around the planet. So this is hard to kind of imagine. So I just refer to some of the YouTube video that well explain and well visualize this orbit in a second. So there is so by the way, this orbit was used for the Artemis 1 project. This is NASA, the lunar, like send a human again to the moon, the kind of project. Artemis 1 is already done. Artemis 2 is coming up in the next year. So Artemis 1 they also use this DR orbit. So if you look at some orbit around, like sending the spacecraft around the moon, you see this near rectilinear halo orbit as well. So what is the difference between the distant retrograde orbit and the near rectilinear halo orbit? The key difference between this DRO and the near rectilinear halo orbit and NRHO are orbit locations. DROs are distance orbit again, and NRHO are the subset of L1 and Lagrange 1 and Lagrange 2 halo orbit families and are located much closer to the moon near the Lagrange points. So orbit shapes DRO have elliptical shape and highly stable, requiring little fuels to maintain, like I said. NRHO have more rectilinear shape and also exhibit good stability, making them suitable for long duration missions. So orbital motion in DRO, the spacecraft orbit the moon in the opposite direction to the moon's orbit around the Earth, giving it retrograde motion. NRHO do not have the retrograde motion, but rather orbit the moon in the same direction as the moon orbits the Earth. So application DRO have been used the spacecraft, this like I already mentioned the China's one, or the NASA's Orion during the Artemis 1 mission. NRHO are being considered for future inhabited facilities in CIS lunar space as they offer favorable stability and accessibility properties. So in summary, DRs are distant, highly stable, retrograde orbits around the moon, while NRHO are closer, rectilinear halo orbits around the moon's Lagrange points with different application for lunar exploration missions. So I'm gonna go to the visualization here. This one. So let's look at the first NRHO near rectilinear halo orbit. Refer to this isolationic. So look at NRHO. So this is the Earth central inertial frame. This is Earth moon rotating frame. So if you look at the moon, it's elliptical, and the moon centered inertial frame is like this. So it looks quite stable, but they need some burns after apply a small maneuver once a week to remain in orbit. So but it looks quite stable and quite simple, I would say. So let's go to the distant retrograde orbit. So refer to Scott Manley videos.
So here's what the trajectory looks like from NASA's eyes on the solar system. You can see Artemis there. It's about to have an encounter with the moon, and it gets kicked around on the inside, going faster than the moon. Now, from this point, it's slowing down because the moon is applying its gravity to it. The moon pulls around the inside lane, passes between the Earth and the moon. That's what we saw. Now Artemis is behind it, and it's getting accelerated again back towards the moon. But at this point, it makes a maneuver to send itself back to the moon so that it can swing around the moon and head homewards. So it's kind of hard to appreciate from this angle. It actually sort of flips itself down below the plane of the Earth so that it then comes up sort of over the Pacific so it can be recovered. So here...
Yeah, something like this. So it's fully used the sort of Earth's the gravitational field and Moon a gravitational field. They don't need to use much fuels to remain in the orbit. Also, it's quite useful for the short term because they can come back to the Earth by using the Earth's gravitational field. That's what it looks like to me. So okay, let's go to the next second news. Japanese lunar lander company. This is also about the moon. Company ispace raises 53.5 million in stock sales. So Japanese lunar lander developer has raised 53.5 million in stock sale to help fund development of upcoming missions. So they are doing several missions. So this is partially success, but like a landing was a little bit failed. Lunar landing mission 1. The first mission was planned to perform a soft landing on the moon. And the second one, this is something they are trying to do in this year. The second mission will perform a soft landing and deploy the rover for the surface exploration and data collection to the moon. And from the mission 3 and so on. From mission 3, Deep Beyond will increase the frequency of lunar landing and rover expeditions to transport customers' payload to the moon. Our landers will deploy swarms of rovers to lunar surface to pioneer the discovery and development of lunar resources, enabling the steady development of lunar industry and human presence on the moon. So this is ispace. They just got like go to the stock market, open market. Their stock, honestly, it's not doing quite well. I mean, it's but they have a lot of potential, so some people are bullish on it. I mean, like in the long run, definitely this company is backed by Japanese government. Previously, it was about I cannot find the number here. Yeah, this one, Japanese government worth 12 billion yen. So this is like 80 million USD. In 2023, they got a grant from Japanese government for the mission to work on the mission 6. So what they did is basically they sold a lot of stock. March 28, that completed the sale of 10.25 million shares of stock, rising approximately 8.5 billion yen. This is equal to 53.5 million USD. The shares were sold to institutional investors, also Japan. So institutional investors is it could be like bank or like pension funds, that kind of things. It's relatively larger one. It's not like hedge fund. My hedge fund included, but like relatively not short term profit, like not short term. Pursuing that kind of like hedge funds, more like a long-term one and more stable one. That's what it says. So most of the funding will go to this mission 3, the lander being developed by the American subsidiary ispace US for JPER. The Apex 1.0 lander will fly a mission in 2026 for NASA's Commercial Lunar Payload Service program, COPS program. going to the far side of the moon. So this is also the another side of the moon, and explore what's going on in there. A lot of craters and maybe like some hints of the previous existence of the water, that kind of things. So company said like they use the cost for like this and that, but basically they need a bunch of stuff to be done. Like they 2 relay satellites need to be deployed. This built by Blue Canyon Technologies. So this the Blue Canyon Technologies is making a lot of like microsat, a CubeSat spacecraft like this to handle communication between the far side lander and Earth. It is spending 2.5 billion yen. So this is 2.1 billion yen. So it's like 200 million. Okay, let me tell you, 2.5 billion yen. For the part of the cost of the mission launch on the SpaceX Falcon 9, so they use the SpaceX Falcon 9 rocket, and 3.2 billion yen will go towards the production of the lander itself. Okay, so they are in red right now, running the company. They need a bunch of like developers and like and stuff. However, they are the company does sufficient funding for mission 2, which is scheduled to launch near the end of the year on the Falcon 9. So Takeshi Hakamada, the chief executive of the ispace, said at the briefing that the lander is currently in assembly, integration, and test phase the company's facility in Japan. Once system level testing is complete, the lander will ship to the US for launch, and Falcon 9 will launch it. He said ispace believes it has corrected the problem that caused the crash of its first lander, which it blamed on the software problem during the lander's final descent to the surface. We had a great learning from mission 1, especially the landing phase, he said, with improvement to both the lander's hardware and software. We have very strong will to land on the moon next time on mission 2, and like that. So okay, so this is the end of today's daily space. So like this and daily space, that every day I'm trying to tell you like what's going on in the space and business or technology and stuff. So I put all the links that I used for today in the comment section below. So if you like this video, and please hit the subscription button or hit the or like if you have a question, and I leave the comment below. So thank you for watching. See you in tomorrow. Thank you very much. Bye bye.